is Bhupatil, and today we will talk about classification task. So here first we are importing all the required libraries, then we are initializing weights and biases, we will initialize the TensorBoard. After that, we are loading a data set which is fraction and this, and then normalize pixel values between 0 and 1, and will display a few sample images. As you can see, these are all sample images, and we will define our model, and we will compile it. After that, we will train the model with weight, weights and biases logging, and we will evaluate our model. Then in the predictions, we'll talk about predictions and compute and confusion metrics. So this is our confusion metrics, as you can see. Then we will go to classification report. This is our classification report. According to precision, we call it one score support. Then ROC curve. This is our ROC curve, which is receiver with operating characteristics. Then we will move on to precision recall curve. As you can see, this is our precision recall curve. Then along model architecture, we will save and display model architecture. So this is our model architecture. As you can see, then we print our model summary. This is our summary, which is different types of layers that are flattened and dropout and then we have image classification. So in image classification, first we will set for a new project and we will import required library. Then we will start new one DB run and we'll initialize it, then load our data set, then we'll normalize it as usual steps. Then I will reshape the data for CNN input, then we'll convert labels to one-part encoding, and then we'll display info about the data set. These are the infos and they will organize the images. Then we will go in the section of visualizing sample images. So we'll visualize sample images here. As you can see, there are different images here. Then we'll go to design the convolutional neural network model. So here we will construct a deep CNN model that consists of convolution, max pooling, fully connected layer for image recognition. Model equal to model sequence. So we'll define CNN model architecture, then first convolution layer, second convolution layer, third convolution layer, and flat and dense layers. Then we'll compile the model and print the model summary. As you can see, there are different layers here. Then we'll train our model. First, we'll define callback, then we'll define TensorBoard callback, then we'll train our model and we'll evaluate eventually. Then we will start visualizing the training history. So for that, there is a graph of it, model accuracy and model loss, including classification metrics. So in this, we first do predictions, then we'll calculate classification metrics, and then we'll print metrics and generate our classification report. So our classification report will be generated based on precision recall and score support. So then we will visualize the confusion matrix. This is our confusion matrix, and then we'll visualize model prediction. So this is our model predictions visualization. As you can see, incorrectly classified samples. Then we'll create a model diagram, and then we'll display the model diagram. This is the model diagram. And final analysis of image classification model. And this will cross insights of 1 dB. Then we'll plot our graph as for the accuracy, and we'll create the summary for our CNN model, and we'll print out the summary at last. This is the summary of it. This is the graph for class accuracy, and At last, this is the second model for my. Now I will move on to regression. So regression of California housing data set. So first we import all the required libraries, then we'll initialize weights and biases. We'll load the California housing data set and we'll split data set into train and test sets. First, we'll scale feature values using standard scaler, then build the model. First hidden layer, second hidden layer, third hidden layer, fourth hidden layer. So at last, we will have output layer and then we'll compile our model. Then early swapping to prevent overfitting and reduce learning rate if validation loss platinum. Then we will compile all the history. Then we'll train our predictions and then we will calculate metrics and we'll eventually print our results. This is our results, training metrics and test metrics. Then we will import 1 dB. Then log metrics after computing them. Initialize the 1 dB, save our model and print our summary. And we will define the customer function explicitly and load the train model. Then we print summary and generate and then after that we'll display our model architecture. As you can see, this is the summary, this is the architecture. So this was largely featured in my classification and regression. Thank you guys for watching.